So guys, let us start with this projectile motion. I'm writing here. And as stated in the last video, we are going to follow those assumptions, okay, that no horizontal acceleration, only gravitational acceleration acting vertically downwards. Now let us consider this body. This is my ground, okay, and it starts from here and it lands here. Okay, so my initial velocity is in this direction. Okay, it may not be that steep, okay, but then for simplicity, if I draw that arrow, very much touching the profile, it would be confusing. Okay, so I'm just writing it like that. Okay, u is my initial velocity and the angle made with the horizontal is theta, right? O is my starting point here. So it starts from O, moves along the path and reaches point A. So A is the point where it lands. Okay. Now on its way, it is going to pass this point B, which is point of maximum height. Okay. Now, alright, so now I have my initial velocity, angle of projection, this angle theta with the horizontal, that is called angle of projection. Okay, so I have my initial velocity, angle of projection. Now there are few things which I might be interested in calculating. And what are these things? Number one is how much distance it is going to cover here. This distance is called something. Okay, how much distance it is going to be above the ground, so maximum height above the ground. Okay, let us call this something here, right? How much time it takes to reach the maximum height from starting? Okay, that time would be called t1. Then from here, from maximum height, it will take some time to reach the ground. Okay, that would be time t2. Now the moment it was given this initial velocity and till the time it lands on the ground finally, okay, so isn't that time the time of flight? Isn't that the time for which the object is in the flight? Correct. So I would call that time of flight. Correct. I would call that time, let us say t. This time t1, t1 is which time? From starting to reaching maximum height. Okay, so during this time it is ascending, isn't it? So I would call this time as time of ascent. And then t2, in the same manner, I would call time of descent. Time of ascent, time of descent, and time of flight. Okay, I had said I would call this distance something. Now here I would call that distance as range. Okay, now what is range? So once I kick the ball, how much distance, how much horizontal distance it is going to travel, that is called the range of projectile. Okay, I'll call this R. And obviously maximum height reached, so we have to call it something. So why not call it capital H here, or H max for that particular projectile. So we would be calculating all these distances. Okay, now we would be we would be finding the expressions for all of these like T1 and T2 and capital T and R and H and all that. Okay, but for the time being, I'm going to split the videos. Okay, so in the first video we would try to find the time of ascent and time of descent. In the second video we would find the total time of flight. Okay, we can do that. Okay, and and so on. Then finding the range, I would write here range and maximum height. Now one more thing that might come to your mind here is, why did I draw the path like this? Is it always this kind of path, or is the trajectory of this shape? The answer is yes, and there is some reason for that. So first of all, let us prove why it has got this profile. Okay, uh, for convenience. Okay, now we are doing motion in plane, right? And this motion, this velocity is in any direction here with some angle with horizontal. Okay, so obviously what we did in scalars and vectors, we are going to do that. We'll be splitting this velocity into vertical and horizontal components. So my horizontal component here is, let us call it ux, and vertical component is uy. Correct? I know the angle, so my ux, horizontal component of velocity, it is u cos theta, and vertical component of velocity uy is equal to u sin theta. Now, again I go back and remember that there is no acceleration in the horizontal direction. Acceleration is going to be only in the vertical direction, isn't it? So my horizontal component of velocity, that is ux, which is u cos theta, it is going to remain constant. Okay, but vertical component does change. Okay, I throw something up, its speed goes on decreasing. At some point it becomes zero, and from that point of maximum height, it will start coming down. Correct? So my initial vertical velocity is uy. Okay, my vertical velocity at point B, which is point of maximum height, okay, over there my vertical velocity becomes zero. Okay, can I apply this kinematic equations of motion? Yes, I can, because my vertical acceleration, that is acceleration due to gravity, it is constant. So it satisfies the condition for those kinematic equations for uniform acceleration. So I can apply that. Okay, so should I go to this point directly, or should I have some point in between? Because otherwise you would say that you have taken only the boundary conditions, like maximum height, position and all. It wouldn't be much difficult to derive an expression like that. But then here we want to find out why the profile or why the trajectory is like that. Okay, so we want to find that. So why not do something different? Okay, so I'll take any point here. Okay, some point P here. Okay, and coordinates of this point with respect to my origin, they are x comma y. Correct? X comma y. Now time taken to reach this position P. Okay, time taken to reach P is, let us call that time T. Correct? So T is time to reach position P. Alright, now since there is no acceleration in the horizontal direction, my horizontal component of velocity is going to remain constant. So I know that my ux, or u cos theta is constant. So whether my projectile is here or here or here or here or here, my horizontal component of velocity will remain what it was in the beginning, u cos theta. Correct? And for constant velocity or for uniform velocity, how do you get the distance? my velocity, uniform velocity is equal to distance upon time. So my time is equal to distance upon velocity. Now what is my distance over here? What is the horizontal distance? I am talking about horizontal distance because I can apply this equation only to horizontal. Okay, it is uniform velocity, right? What is the horizontal distance covered? Now coordinates with respect to my origin O, they are x comma y. So horizontal distance covered is x upon velocity. What is the horizontal velocity? It is u cos theta. Correct? So time taken is x upon u cos theta. This is my number 1. Okay. Now let us go to vertical motion. My initial vertical velocity, how much was that? Is it not u sin theta? Initial vertical velocity. Okay. And vertical velocity over here. Okay. That I don't know and I don't even want to calculate how much velocity is there. Okay. I am interested in displacement, vertical displacement. Okay. So for displacement, let us use second kinematical equation, and second kinematical equation it is S is equal to ut plus half at square. Correct? Now what is the vertical displacement? Vertical displacement is this, and since the coordinates of P are x comma y, my vertical displacement is y is equal to, what is my initial vertical velocity? Is it not uy, which is equal to u sin theta into t. What is your t? T is x upon u cos theta. Now here acceleration in the vertical direction is gravitational acceleration, and it is acting vertically downwards, so we would obviously be taking minus sign for that, right? So it is minus half g into t square. Now again my t square is x, t would be x upon u cos theta, so x square upon u square cos square theta, right? Now what? Now here you can see that you can cancel this u, and sin theta upon cos theta is tan theta, so it is equal to x tan theta minus g upon 2u square cos square theta into x square. Now you would ask me, why have you written like this? Once the projectile is airborne, it is being acted upon only by g, isn't it? The angle with which it was projected, now it has happened. Okay, no one can do anything about that. So my theta is constant, correct? So if my theta is constant, my tan theta is also constant, correct? Acceleration due to gravity, it is constant at a given place, correct? My initial velocity, see, I have kicked the ball, I have given it some velocity. Is it going to change? No, whatever I have given, okay, it is not going to change. So my u square is also constant, theta is constant, cos square theta is also constant. So what is the variable here? Isn't it only x here and x square there? And if you look at this equation, this portion on the right hand side, it is a quadratic. Right? And what is the profile of a quadratic? It is a parabola, right? And that is the reason why the trajectory of a projectile is a parabolic curve, right? And this equation is called equation of trajectory of a projectile. Equation of trajectory of a projectile. Now we will stop here, and in the next video then we would be discussing about time of ascent, time of descent, and time of flight, and range and height and so on. So but then we are going to do it gradually, I mean to say step by step, right? Thank you so much.